Comprehensive report on Tianwen-1, history, present, and future. Introduction. Tianwen-1, meaning Questions to Heaven, is China's first independent mission to Mars, launched by the China National Space Administration (CNSA). This ambitious project aims to explore the Martian environment through an integrated approach that includes an orbiter, lander, and rover. This report provides a detailed overview of Tianwen-1's history, present status, and future prospects. History and background. Initiation of the Mars mission. China's interest in planetary exploration began in earnest in the early 2010s, following the successful lunar missions like Chang'e 3. The desire to explore Mars intensified, leading to the formal approval of the Tianwen-1 mission in 2016. Prior to this, China attempted its first Mars mission, Tianwen-1, in collaboration with Russia in 2011, but that mission failed due to a launch failure. Launch and journey. Tianwen-1 was successfully launched on July 23, 2020, from the Wenchang Space Launch Site using a Long March 5 heavy-lift rocket. After a journey of approximately 7 months, covering a distance of around 470 million kilometers, Tianwen-1 entered Mars orbit on February 10, 2021. Mission objectives. Tianwen-1's scientific objectives are comprehensive and include 1. Investigating the geological structure and historical evolution of Mars. 2. Analyzing the surface and subsurface characteristics of Martian soil and searching for water ice. 3. Measuring the Martian atmosphere and climate. 4. Exploring Mars' internal structure and magnetic field. 5. Searching for evidence of past or present life. Key milestones. 1. Launch, July 23, 2020. 2. Mars orbit insertion, February 10, 2021. 3. Landing on Mars, the lander successfully touched down on May 14, 2021, in the Utopia Planitia region, making China the third nation to achieve a soft landing on Mars. 4. Rover deployment, the Zhurong rover was deployed from the lander on May 22, 2021. Current status. Operational success. As of 2023, the Tianwen-1 mission has successfully completed its primary objectives. The orbiter and the Zhurong rover have returned a wealth of data, with over 420 gigabytes of scientific information collected. The following highlights illustrate the current status. Orbiter functionality. The Tianwen-1 orbiter continues to operate effectively, conducting ongoing scientific observations of Mars and relaying communications for the Zhurong rover. Rover operations. Zhurong has operated beyond its initial 90 Sol approximately 93 Earth days mission, extending its exploration of the Martian surface. Scientific contributions. The mission has provided critical data on Martian geology, atmospheric conditions, and potential water sources, contributing to our understanding of the planet's history and habitability. Challenges encountered. While Tianwen-1 has achieved significant milestones, there have been challenges. In 2023, Zhurong lost contact with mission control after failing to wake from a scheduled hibernation period, likely due to accumulated dust on its solar panels. This situation remains a concern, as it affects the rover's ability to continue its exploration. Future prospects. Planned missions. The success of Tianwen-1 lays a strong foundation for future Mars exploration missions. CNSA has outlined ambitious plans for continued planetary exploration, including 1. Mars Sample Return Mission, expected to launch in the 2030s. This mission aims to retrieve samples from the Martian surface and return them to Earth for detailed analysis. 2. Jupiter missions. CNSA is also considering missions to explore the gas giant and its moons, expanding its planetary exploration portfolio. 3. Further Mars missions. Additional missions to Mars may include more advanced landers and rovers equipped with improved scientific instruments. International collaboration. CNSA has fostered international partnerships in its space exploration endeavors. Collaborations with countries such as France, Argentina, and Austria have enhanced the mission's scientific capabilities, especially in areas like spectroscopy and magnetometry. Future missions may continue to build on these collaborative frameworks. Conclusion: Tianwen-1 represents a significant milestone in China's space exploration efforts, marking its entry into the exclusive club of nations capable of conducting successful missions to Mars. The mission not only showcases China's technological capabilities but also enriches global scientific knowledge about the Red Planet. As China looks to the future, the lessons learned from Tianwen-1 will undoubtedly shape the trajectory of its ambitious interplanetary exploration program. The journey of Tianwen-1 is a testament to human curiosity and the relentless pursuit of knowledge about the cosmos. As we await further developments from this groundbreaking mission, it stands as a symbol of hope and ambition for future generations of explorers. Counterintuitive information in the content about Tianwen-1. 1. China's first independent Mars mission. It may come as a surprise that Tianwen-1, which successfully landed on Mars and deployed a rover, is China's first independent Mars mission. Prior to this, China attempted a Mars mission in collaboration with Russia, which failed. This highlights how much progress China has made in space exploration in a relatively short time, particularly given that many nations struggled to achieve successful Mars missions for decades. 2. Simultaneous launch window. The Tianwen-1 mission was launched during the same window as two other major Mars missions, the UAE's Hope orbiter and NASA's Perseverance rover. This collaborative timing among different countries competing in space exploration is a unique scenario, demonstrating that nations can share a common goal of exploring Mars while still competing for scientific discovery. 3. First attempt success. Contrary to the typical narrative that Mars missions often fail on the first attempt, Tianwen-1 became the first mission to successfully orbit, land, and deploy a rover on its maiden attempt. This contrasts sharply with the historical trend where many nations, including the USA and Russia, faced failures during initial missions to Mars. 4. Autonomous operations. The level of autonomy required for Tianwen-1's operations is noteworthy. Given the vast distance between Mars and Earth, there is a significant communication delay up to 22 minutes round trip. Tianwen-1 had to perform critical landing maneuvers autonomously, which is a technical feat often underestimated in discussions about space missions. 5. Cultural significance of the name. The name Tianwen, which means questions to heaven, is derived from a classical Chinese poem. This philosophical underpinning contrasts with the scientific and technological narrative typically associated with space missions, suggesting a deeper cultural significance behind China's endeavors in space exploration. 6. International collaboration. Despite being a Chinese-led mission, Tianwen-1 involved contributions from multiple countries, including France and Austria, for specific instruments. This global collaboration is often overshadowed by nationalistic narratives in space exploration, illustrating a more interconnected approach to addressing the challenges of interplanetary missions. 7. Data volume. The amount of data collected by Tianwen-1 and the Zhurong rover, over 420 gigabytes, is substantial considering the mission's duration and the technological constraints of operating at such distances. It challenges the perception that data collection from Mars is limited and showcases the advanced capabilities of modern spacecraft. 8. Rapid mission development. The speed at which China developed the Tianwen-1 mission, going from a failed collaboration in 2011 to a successful independent mission in 2021, highlights an accelerated learning curve and technological advancement in China's space program. This rapid development contrasts with the long timelines associated with many space missions. 9. Zhurong's extended mission. The Zhurong rover was initially designed for a mission of about 90 Earth days, yet it has outlived this timeline and continued operations. This raises questions about the reliability of mission planning and the potential for technology to exceed expectations in extreme environments like Mars. 10. Presence of water ice. The hypothesis that Mars may have large amounts of water ice buried beneath its surface was notably emphasized by the Tianwen-1 mission. This challenges the earlier narrative that Mars was completely dry, suggesting that there could be more to the planet's potential for past life than previously thought. 11. Comparison to historical missions. While the narrative often focuses on the successes of NASA and the Soviet Union, the Tianwen-1 mission's accomplishments in the context of a relatively new space program is a counterintuitive point. China has quickly positioned itself among the leaders in Mars exploration, effectively reshaping the historical context of space exploration. These points illustrate the complexities and nuances of the Tianwen-1 mission, providing insights that may challenge preconceived notions about space exploration, particularly in the context of China's rapid advancements in this field. The Tianwen-1 mission, China's first independent Mars exploration endeavor, marks a significant milestone in not only China's space ambitions but also in the global efforts to understand the Red Planet. While many aspects of the mission have been covered in detail, there are several important points that may be overlooked by the general public, which hold substantial significance for the future of planetary exploration and international collaboration in space science. 1. Cultural significance of the name Tianwen. The name Tianwen, meaning questions to heaven, derives from an ancient Chinese poem by Chu Yuan, a revered poet from the Warring States period. This cultural reference is not merely a name, it embodies the philosophical and existential quest inherent in humanity's exploration of the cosmos. The choice of such a name signifies China's blending of traditional cultural values with modern scientific pursuits, emphasizing a continuous quest for knowledge and understanding. This cultural aspect may resonate deeply with the Chinese populace and serve as a source of national pride, reflecting the ambition to contribute to humanity's broader understanding of the universe. 2. Technological innovations and challenges. The Tianwen-1 mission is notable for being the first to attempt a combined orbiter, lander, and rover in a single mission on its maiden attempt. The technical challenges involved in achieving a successful Mars landing cannot be overstated. Previous missions by various countries have often faced difficulties at one of these stages, particularly landing. Tianwen-1's successful landing and operation highlight significant advancements in China's aerospace technology, particularly in autonomous navigation and hazard avoidance during descent, which are critical for future missions not only to Mars but to other celestial bodies. Furthermore, the mission's reliance on a combination of technologies developed through China's successful lunar exploration programs showcases the iterative learning process in space exploration. The successful implementation of these technologies is vital as China gears up for future missions, including plans for Mars sample return missions in the 2030s. 3. Scientific goals beyond water detection. While much of the media coverage has focused on the search for water ice, an essential component for potential human habitation and understanding of Mars' past habitability, Tianwen-1's objectives extend far beyond this. The mission aims to conduct a comprehensive geological survey and analyze the Martian atmosphere, magnetic field, and soil composition. The significance of studying Martian geology cannot be understated. It provides insights into the planet's history, including volcanic activity, climate shifts, and potential biosignatures from ancient life. Understanding Mars' geological history is crucial for piecing together the environmental conditions that could have supported life, which in turn informs our understanding of Earth's own geological processes and climatic changes. This broader scientific objective enhances the mission's importance in the context of planetary science. 4. Impact on future international collaborations. The Tianwen-1 mission has also set a precedent for international collaboration in space exploration. Although predominantly a Chinese endeavor, it has integrated contributions from various countries, including France and Austria, which provided scientific instruments and technical assistance. This collaborative spirit is essential for the future of space exploration, as no single nation can bear the cost and complexity of deep space missions alone. Such partnerships can facilitate knowledge sharing and foster a sense of global community in scientific inquiries, potentially leading to more ambitious projects, such as crewed missions to Mars or joint sample return efforts. The success of Tianwen-1 could encourage other nations to pursue similar cooperative ventures, thereby enhancing international relations through shared scientific goals. 5. Lessons from communication delays. An often overlooked aspect of the Tianwen-1 mission is the inherent communication delay with Mars, which can range from approximately 4 to 24 minutes one way. This delay necessitates a high degree of autonomy for the rover and lander, compelling engineers to design systems that can make critical decisions without real-time human input. The experience gained from managing autonomous operations during the Tianwen-1 mission will be invaluable as space agencies consider future missions to more distant destinations, such as the outer solar system or beyond. Understanding how to efficiently program autonomous systems to handle unforeseen situations will be critical as humanity pushes deeper into space. 6. Broader implications of Mars exploration. The significance of Mars exploration transcends mere scientific curiosity. It has profound implications for humanity's long-term survival and potential colonization of other planets. As Earth faces challenges such as climate change and resource depletion, the exploration of Mars offers a potential backup for humanity. The data collected by Tianwen-1 could provide critical insights into the feasibility of human colonization of Mars, shaping future policies and priorities for space exploration. Moreover, the study of Martian soil and atmosphere can inform our understanding of how to sustain life in extraterrestrial environments, leading to advancements in technology and life support systems that may one day allow humans to live and thrive on another planet. Conclusion. The Tianwen-1 mission is a landmark achievement in space exploration, rich with implications that extend far beyond its immediate scientific goals. Its cultural significance, technological innovations, and potential for fostering international collaborations highlight the mission's role in shaping the future of planetary exploration. By appreciating these often overlooked aspects, we can better understand the profound impacts of Tianwen-1 on our quest for knowledge about Mars and our place in the universe. 1. Historical significance and technological achievements. Tianwen-1 represents China's first independent Mars mission, marking a monumental milestone in the country's space exploration history. Launched on July 23, 2020, and successfully entering Martian orbit on February 10, 2021, it made China the third nation to achieve a successful landing on Mars and the first to deploy an orbiter, lander, and rover in a single mission. This accomplishment reflects significant advancements in China's aerospace technology, particularly in autonomous navigation, landing strategies, and deep space communication systems. The mission's name, inspired by the ancient Chinese poem Tianwen Questions to Heaven by Chu Yuan, symbolizes humanity's enduring quest for knowledge and understanding of the universe. 2. Scientific objectives and contributions. The scientific goals of Tianwen-1 are comprehensive and multifaceted, focusing on the geological, climatic, and atmospheric characteristics of Mars. Key objectives include mapping Mars morphology, studying surface soil composition and distribution of water ice, and investigating the planet's internal structure and magnetic field. The rover, Zhurong, is equipped with 6 scientific instruments, including ground-penetrating radar and mineralogical spectrometers, and has already contributed to a wealth of data, over 420 gigabytes, enhancing our understanding of Martian geology and climate. The findings from Tianwen-1 are expected to play a crucial role in assessing Mars' past habitability and informing future exploration missions. 3. Operational challenges and outcomes. Tianwen-1 faced numerous operational challenges, particularly during its entry, descent, and landing phases, which are often described as the 7 minutes of terror due to the complex sequence of maneuvers required for a successful landing. The mission demonstrated China's capability to independently handle these challenges, achieving a soft landing in the Utopia Planitia region on May 14, 2021. The rover's operation extended beyond its initial 90 Sols Martian Days mission, reflecting its robustness and the effectiveness of its engineering. However, the rover lost contact in 2023 after failing to wake from its winter hibernation, highlighting the inherent risks and uncertainties of planetary exploration. 4. Future implications and exploration goals. The success of Tianwen-1 lays a strong foundation for China's future ambitions in planetary exploration, including plans for a Mars sample return mission in the 2030s. This mission is expected to not only advance scientific knowledge but also enhance China's strategic position in the global space exploration landscape. The lessons learned from Tianwen-1 will inform subsequent missions, potentially including missions to Jupiter and other celestial bodies. As space exploration becomes increasingly competitive, Tianwen-1 underscores China's commitment to advancing its space program and contributing to the global understanding of our solar system. 1. Mars 3 Soviet Union, 1971. The Mars 3 mission marked a significant milestone in space exploration as it was the first spacecraft to successfully land on Mars. Launched by the Soviet Union, Mars 3 achieved a soft landing on December 2, 1971. However, the lander transmitted data for only 20 seconds before losing contact, making it one of the most enigmatic missions in Mars exploration history. The mission aimed to study the Martian atmosphere, surface, and geological features, but its abrupt end left many questions unanswered. 2. Viking program NASA, 1976. The Viking program consisted of two spacecraft, Viking 1 and Viking 2, both of which successfully landed on Mars in 1976. These missions were pivotal in providing the first close-up images of the Martian surface and conducting extensive scientific experiments to search for signs of life. Viking 1 landed on July 20, 1976, and Viking 2 followed on September 3, 1976. Together, they conducted biology experiments, analyzed soil samples, and provided valuable data on the Martian atmosphere and geography, setting the foundation for future Mars exploration. 3. Mars Pathfinder NASA, 1997. Launched in 1996, Mars Pathfinder was a groundbreaking mission that successfully landed the Sojourner rover on Mars on July 4, 1997. This mission was notable for its innovative landing technique, using a series of airbags to cushion the impact. Sojourner became the first successful rover to explore the Martian surface, analyzing rocks and soil, and transmitting images back to Earth. The mission provided critical insights into the geological history of Mars and demonstrated the feasibility of using rovers for planetary exploration, paving the way for subsequent missions like Spirit and Opportunity. Future outlook for China's Tianwen-1 mission. Introduction. China's Tianwen-1 mission, launched on July 23, 2020, marked a significant milestone in the country's space exploration efforts, particularly in the realm of planetary exploration. The mission achieved multiple objectives, including successful orbit insertion, landing, and the deployment of the Zhurong rover on Mars. As we look ahead to the next decade and beyond, the future outlook for China's Mars exploration and its implications for global space endeavors is promising. Continued data collection and analysis. As of early 2025, the Tianwen-1 orbiter has successfully collected over 420 gigabytes of data, contributing valuable insights into Mars geology, atmosphere, and potential for past life. The orbiter's scientific instruments, including the Mars Orbiter Magnetometer and Mars Mineralogical Spectrometer, will continue to analyze Martian surface features and atmospheric conditions. This ongoing data collection is expected to enhance our understanding of Mars and support future missions. Implications for Mars sample return mission. The success of Tianwen-1 lays the groundwork for China's planned Mars sample return mission, targeted for the 2030s. This mission aims to retrieve Martian soil and rock samples for analysis on Earth, allowing scientists to conduct more detailed examinations than what is possible with remote instruments. The experience gained from Tianwen-1 will be crucial in developing the technologies and strategies required for sample collection and return. Expansion of China's planetary exploration program. Following the success of Tianwen-1, the China National Space Administration (CNSA) is poised to expand its planetary exploration initiatives. Future missions may include a Jupiter orbiter and proposed missions to icy bodies and even interstellar exploration. This expansion reflects China's ambition to become a leader in global space exploration, alongside other major players like NASA and ESA. International collaboration. China's approach to space exploration increasingly emphasizes international collaboration. The Tianwen-1 mission has involved partnerships with various countries, including contributions from French and Austrian scientists regarding scientific instruments. As China's capabilities continue to grow, we can expect more collaborative efforts with other nations, fostering global scientific advancements in planetary science. Advancements in space technology. The technological innovations developed for Tianwen-1, particularly in areas such as autonomous navigation, landing techniques, and scientific instrumentation, will enhance China's capabilities for future missions. Lessons learned from the mission's successes and challenges will inform the design of subsequent spacecraft, enabling even more ambitious exploration endeavors. Mars human exploration aspirations. Though still in early stages, China's long-term vision includes the potential for human exploration of Mars. The experiences gained from robotic missions like Tianwen-1 will inform the strategies and technologies needed for future crewed missions. China's commitment to advancing its human spaceflight program could eventually lead to manned missions to Mars, marking a new era in space exploration. Conclusion. The future outlook for China's Tianwen-1 mission and its planetary exploration program is characterized by continued scientific discovery, technological innovation, and international collaboration. As China builds on the success of Tianwen-1, the contributions to our understanding of Mars will be invaluable, paving the way for future missions and possibly even human exploration of the Red Planet. The next decade promises to be an exciting time for planetary science, with China playing a prominent role in shaping the future of space exploration.